So TWI is really excited to be partnering with Pinweld again on a new project. The previous project where TWI worked with Pinweld was assessing really the feasibility of welding thermoplastic sheet of varying thicknesses, and at the end of that project that showed really exciting opportunities in a whole range of new applications for continuous welding. The new project is a much larger programme of work, and that's really to develop that technology, the Pinweld technology, for welding thermoplastic pipes, and in particular polyethylene pipes for the water industry.
So what is Pinweld? Pinweld is an oscillating induction-based system that's particularly low energy, less than 40 watts in fact, that oscillates a pin within the joint of the plastic, creating a tunable weld. We can tune it for better strength or better ductility, depending on the application and the customer's needs. The equipment is supportive of existing solutions. It allows for the cradles that are in common use to be used, the systems, whether you're talking linear or maybe for pipe application. It's not a case of retooling and the costs that brings. The self-governing systems that are in place allow for the optimization of these welds. This AI and machine learning allows the weld quality to be enhanced every single time, whether you're out in the field or whether you're in an industrial setting, the weld quality is maintained every time.
So TWI will be supporting Pinweld throughout the project. Primarily and initially, we're going to be looking at developing optimised conditions for thermoplastic sheet, and then we're going to manufacture welds using the existing jointing technologies. Now those welds will be butt fusion, electrofusion and socket fusion welds using existing welding conditions, and then we're going to test those welds to industry-specific standards. Following that, we want to manufacture Pinweld polyethylene pipes, primarily, using the optimised conditions that we developed for welding thermoplastic sheet. And then we want to conduct, again, industry-specific standard testing on those pipe welds. Now that will be wasted tensile testing, looking for ductile failure, optical microscopy, and then hydrostatic pressure testing of whole pipes.
Well, hopefully you now have a better understanding of the Pinweld technology and the role TWI play within the specific project and the level of testing which will be applied to the process over the next 20 months or so. This is now the second round of funding from Innovate to support the Pinweld technology, which has moved on from welding thin sheet plastic to car bumpers to more complex geometries. But what's so exciting this time is the level of controls and intelligence we'll be bringing to the welding process through the use of AI and machine learning. Neat, strong, repeatable welds every time across a range of environmental conditions. Now from a pipe welding perspective, what makes this different is a defect-free joints through an automated weld and test solution or fit and forget for installers. Additionally, there's the low energy uses explained by Kevin, less than 40 watts. Possible because the focus is just on a single pin rather than heating a whole plate as used with other methods of pipe joining. All of this equates to cost savings, operator safety and reduced emissions. Pinweld have been fortunate to have been involved with the Water Research Centre in the early days of our journey. So they know about us, they know about the technology, and as a result we're aware of the many issues surrounding the water sector, especially the need for ultra-low loss new networks, pipe repairs without excavation, and a reduction in leakage of 50% by 2050. We feel the Pinweld technology will achieve these ambitious targets and requirements, but we can't do this without industry support. For this process to be successful, it will require collaboration, thinking, and investment to get the product to market. But with the right level of commitment, this new system could be working alongside current joining methods on new networks by 2028. That's just 5 years' time. There's phones and the smartphones. The Pinweld process is, in our opinion, smart welding.